Hello, everybody. Let's talk about binomial option pricing in practice. So our starting point is going to be a blank Excel file, and we want to start from scratch and see how we can actually implement this binomial option pricing in practice. Now, the stock that I want to do, it's not a stock to be honest, it's an ETF, but it's IWM, iShare of Russell 2000 ETF. And we want to do option pricing for this. So let's get started. The very first thing that we want to do is to calculate maybe the standard deviation. One thing that we can do is to first download the data. The way I can download the data is this. I can go to stock history, and in stock history for the stock, I can say IWM. And then for the starting date, I can just say, let's say today minus 365. So it would be a year ago. And then for the end date, I can just say today. And do I want it daily? Yes, I want it daily. Do I want header? No. Do I want dates? Sure, why not? Do I want close? Yes. End of the day prices. So this is how we can just download the data. It takes 1 second, but I got all the data. Yes. Now, this is all the data that I have, and that's a very good thing. Let me just copy all of this and then maybe paste them here. I'm going to just paste them as values, paste special values, and oops, it didn't paste them as values. If I just uh, copy everything, go here, and then here maybe paste special values. Okay, and I can just give these columns names. Maybe this is dates, and this is price. And so to be honest, we don't need these sheets. Or I'm gonna just maybe keep the formula that I used here just as a reference. So I'm gonna copy the formula here so I know what formula I used to download data. Great. Otherwise, I don't need this tab. So here I got all the data, and uh, let's do something. Let's calculate the growth, and from growth I can calculate maybe uh, the standard deviation in growth. Yes. So I can just say the growth would be equals natural log or ln of this divided by this, and hit enter and calculate this for all of the cells. Perfect. So this is the daily change, the daily growth that we have in percentages. Yes. So now that we got all of this, I can easily calculate the daily, let's say, daily standard deviation. And it's calculated as std ev.s, and then I select all the growth that I got here, and then so right here I got daily STD. Now, in order to calculate annual STD, I have to do this equals this times square root of SQRT of 252. This is the formula to convert daily STD to annual standard deviation, and it's 0.23. Nice. I got this 0.23. Now so I'm gonna call this STD calculation, standard deviation calculation, calc, and after that, let me open another tab, maybe call it one period, one, and I want to do call option, one call binomial pricing, BP, binomial. So the items that we need. Number one thing is, let's say, um, I need the stock price. So stock price. And we show that the stock price, we can just go to the market and see here 235.73, 235, 235, 73, 235, 73. Good. That's one piece of information that I wanted. So I'm going to write here call option, and then let's say let's choose the end of the option that we want to do. We can do whatever we want. Yes. Right now, how about we just calculate it for December 31st? So it's 38 days up to expiration dates. So I can say T is 38 days. And I gotta divide this 38 days to expiration date by 365 because T is time to expiration day in years. Yes. So time to expiration in years. Let me just have this also here, and then here I just use S. Let's say what else? Strike price. Strike price. What strike price I want to do? I can do whatever I want. However, what if we take a look at 250? Yes, let's see 250. 250. Well, let's do 240. Yes, let's do 240. So right now, 240, the option price is $5.41. Okay. So what else do I need? Another thing that I need is uh, risk-free rate. Right now, risk-free rate is 0.041. So risk-free rate. And again, let me keep the explanation on the right side here. I'm going to just keep that letter. D, dividends that it pay. Or let's use that with Q. So this is dividend yield. So let's see. Do we have that here anywhere? Uh, no. Okay, let's Google that. Uh, IWM dividend yield. And we can just find, we will see that it's the current dividend yield for IWM is approximately 1.01 to 1.02 based on the last 12 months. So it's 2.41. Let's use, here it says it's 1.02. Let me use that one, 1.02%, which is 0.0102. Nice. So I got S, and then number of time periods here, let's say n equals 1, n. Number of binomial periods is 1, and therefore H is T divided by N. So I got that one too. What other information? So this is number of binomial periods. Number of binomial periods. We're going to do 2 and 3 as well. And then H, time lag in years between periods. Okay, so what else do I need? I need a standard deviation, STD. Some books use letter sigma for this, but it's okay. We can just write STD. STD, sigma, or volatility, I know. So I'm going to just also write it here, standard deviation. And amount of standard deviation is, I just calculated that, is this much. I'm gonna paste this as values. Great. So yeah, I think we got everything and we can get started. Now, here in option pricing, number one thing, the first things that you wanna calculate are these. So number one, U and D, and then number two, probability, and one minus probability. Okay, so the formula for U is E to standard deviation or sigma square root of H. So U, I'm going to calculate that here. U is EXP, exponential function of, then here I got standard deviation times SQRT of H. Wonderful. That's U. D is opposite of this, or I can just use this formula and put a negative sign right here, or I could just say easily negative 1 over that, 1 over U. Then next one is P. How do we define P? P is, so numerator is E R minus, so this delta is just standard, is dividends, yes? R minus Q times H minus D over U minus D. Let me form that. P is equals, so in the numerator we have this. EXP, EXP of, and then R minus H times R minus Q times H, R minus Q times H, R minus, sorry, let's fix this, R minus Q, so times H. Make sure that this is inside exponential. So here we got exponential of this times H, and then I close the exponential here. So this parenthesis for this parenthesis for this, and then the whole thing minus D, then I close the parentheses over U minus D. Perfect. 0.5029. A little bit greater than points, like 50%. And then Q, sorry, 1 minus P would be equal, is equal to 1 minus this guy. Perfect. I calculated UDP 1 minus P. Now this one is super easy because it's uh, this one is just one time period, and I can just say here, let's say S and C, and then here the values that we have, S equals this, C is the thing we want to calculate. Here I'm going to calculate SU, and here CU, and here SD, and then here CD. So here SU is equals this guy times U, and then this is equals, and then here, by the way, it's a good idea to also, whenever we are referencing a cell, put a dollar sign so we know that this is where we are fixing these things. Yes. So how about I just put a dollar sign here because I know this is fixed. Okay, and then here the same thing because I want to fix this times uh here the cell for U is constant, this one, and then here is this cell times this cell, and I put the maybe dollar sign here. It doesn't hurt. Now what's the formula for CU? CU is max 0 and then this minus strike price. So strike is 240. I want to fix the strike price, but not that's SU. So then, because later on I want to use this formula and put it right here. Oops. Here, here. You see? Perfect. And then, so as we have the formula for C0, I can just call this maybe C0. It makes more sense. And this is also maybe S, some books they just call it S0. So we know its initial price. And then how about the formula here for C0 for C0. So let's take a look at the formula that we had right here. It's expected value of, first we calculate the expected value of this option, and then we discount it to today's dollar. So E equals EXP negative RH, negative R times H times, then we can say P times this guy, and I can fix this P, so times this plus 1 minus P times, let me also fix this one, times this. 115. So I did something wrong. Let's see what I did wrong. So, oh, I should have said this times G16, not 15. Here we go. Great. So prediction of 1-3 binomial model is $6.98. And just as a reference, we can write here actual if we want. It's just something for fun. Actual price is, and that let's take a look at the actual price here for the 240, $5.41. $5.41. $5.41. Okay. So this is 1-3 binomial call option. Perfect. Now let's move to two periods binomial model. So I'm going to just copy this and oops, what happened? Move or copy, create a copy. Okay. I'm going to call this maybe two periods, two call option binomial. And then what I want to do is this. So I want to have another, here it's going to be SUU, CUU. They're here, SUD, CUD, and here SDD, CDD. Okay. So, and then these things, they are not, uh, like this is correct, but these are not correct. Yes. So later on, we are going to change it. So SU, okay, I'm going to delete this and then delete this as well. So SUU is essentially this times U. Make this smaller times U. And then SUD is this times D, which should be exactly S because U and D, the multiplication of U and D is 1. So if I'm doing U times D, that should be just S, which is 235.73 exactly. Perfect. And then this one is this times D. Great. And then, so the formula here is max. Then we would say max 0 and this minus strike price. And I want to fix the formula for strike price because I don't want that to change. It would be always minus strike price. But here I copy this and then here. Perfect. Now I can use the formula I had here. Yes. And I can just copy this formula and paste it here and paste it here. So essentially, this one is using CUU and CUD for option pricing. Yes. So it says B14, which is P times I10, which is this, plus B15, which is 1 minus P, times I14, which is this. And then take everything, just calculate uh, the here. Oh, I made a mistake here. Let's here. I should have fixed maybe these things. Uh, negative B5. Uh, so I'm gonna fix this risk-free rate. Then here B8 negative R edge is close, but if you want to move that formula, then that's not gonna carry. So I'm gonna do this. And then yeah, now it's correct. So this one gave me a worst approximation. For one call was $6.98. For two call is $8.42. So it gave me a little bit of worst approximation for C0, which is higher than before. But everything here looks good. Exponential of R times H, which is, yeah, the discounting factor that we have in negative side. And P times that minus plus 1 minus P times this. Perfect. Okay. So let's move on to 3 time period binomial, and that's going to be the last one that I want to do for call option. So I can just again move or copy and then use this one to call binomial. So I create copy of this and then Call binomial. Okay. So now how can we do this? So first of all, I'm gonna just copy these names, paste it here, and then this one is gonna be CUU, and then call it CUU, and then here it would be SUUD and CUUD, and then here is SUDD, then here's CUTD as well. The last one is going to be SDDD and CDDD. So we can easily calculate these. So this is equal uh, so this times u. And then this one equals, you can just say this times u. This one is this times d. And then this one is SDD times D. Perfect. And they make sense. The prices, they're going down. Yes, great. Now that we did this, I can easily calculate uh, option prices at the last node. So it's equals max and then, oops, equals max and then 0 and this minus uh, strike price. So let's fix the strike price so we know that that's not going to change. Dollar sign, dollar sign. Use this formula here, use it here, use it here. I got all the option prices at the way end. Now you have to calculate these. Yes. This is, let me just delete this. So again, this works backward. At the way you start from the last binomial tree, and by last node you calculate SUUU, SUUD, and which essentially SUUD is SU. So these two numbers are exactly the same, and then these two numbers are exactly the same. And then you calculate the call option. From the call option at the last node, you calculate the call option at one to the last node. How? Again, the formula that we have. Yes, the formula is this. I'm going to copy this formula, then click it here, here, and here. Let me make sure that the formula is right. Yes, it says exponential of negative exponential of r times h. And then, oh, I made a mistake here. And also in the call too, we're gonna see what the problem is, but it's an easy fix. So here negative R times H. So this one times this guy, grade times B14, which is P times this, uh, plus this one B15 times this. Okay. Now the mistake that I did here in binomial option pricing for two time periods, here I forgot to change 1 to 2. I have to do that. And then look at this, 8.42, it changed to 5.49. So much more accurate number. And then here, I gotta change this to 3. Let me just calculate everything and then change that to 3. Let me make sure that this one looks good. And then this one looks good. And then, yeah, this one looks good. This one looks good. This one looks good. So let's change this to 3 and 5.82. So this is what we got for this. Okay, so we got all the option pricings for the call for these three. So again, remember that you start from the last node. You calculate SUUU, which is SUU times U, and then here the same thing. It's SUD times U, or we could just say SUU times D. They are the same. And then here, and then also here. So we calculated all of that. Then we calculated the options. The options are maximum of this minus the strike price. I fixed the strike price so I can copy the formula here, and then here, and then here. Then I calculated this based on expected value of these. So this times probability of that plus this times probability of that. So expected value of uh, options here, then times. So you gotta use this discount factor. Yes, you gotta make a after you gotta convert that to present value. So we did that, so we are all good. Now everything looks good. Uh, what else? What else can be done, and what else is due? Let's just do put options. So I did one call, two call, three call, and then I'm gonna copy this, move or copy. I'm gonna copy the whole sheet. Call it one put binomial. Okay. So the only change in call and put and call is here option prices at the last node. It's going to be this guy, like a strike price. So here strike price minus this. And then copy the formula here and paste it here. And boom. This one is calculated as well. Yes. Perfect. Let's just take a look at the actual price that we have. Actual price for puts of 240. And it doesn't have to be, we can easily change the K or strike price. So let's go to actual data and I'm going to put this on buy put and 240. It's 9.53. 9.53. Okay. One down, two more puts to go. Let's see how we can do the rest of them. Yes. So here I'm gonna do this. Let's get the call here. Move or copy. To call binomial, create copy. I'm gonna copy this and say to put binomial. And then here, so we can just say, let's change the formula here. Minus this. Yes, so put when price goes down, we make more profits. And good, based on that, we could calculate all of this. And copy the price here. We got almost 9 and it's $9.53. Okay, that's put for 2 and then I'm gonna do put for 3 as well. So let's copy this one. Create copy, 3 call binomial. Let's call this 3 puts binomial. Great. And then get this formula, change it to this minus this. And copy this, paste, paste, paste. Great. So here, yeah, I got, yeah, everything is perfect. I got 9.351 and let's just actual price is again 9.240 9.9.53. Yeah, so copy that and three puts 9.453. And you can see that the number is getting more and more accurate. So 3 put binomial is definitely more accurate than 2 put binomial. Oh, okay. How do we move this? Okay, it doesn't matter. So here, for 3, I got this, which is very close to this. But here I got 9, and then here I got super crazy number. Okay. So this is the way we calculate the, yeah, one uh, period binomial call, two period binomial call, three period binomial call, one period binomial put, two uh, period binomial put, and three period binomial put. And we saw that the number that we got is here relatively close to what we have here. A little bit bigger, and the same about this one. Three put, that's also very close. Perfect. Thank you very much, everybody. Just wanted here, this is the way that we can calculate easily any option pricing. But just to sum it up, from starting from the materials, very first thing, just calculate UDP1 minus P. Then make this graph, calculate SUUU, SUUD, SUDD, and then SDDD. From that, you can easily calculate the option prices at the very last node, and then option prices at the nodes before them is just easily calculated by the formula that we have right here. Yeah, right here. So you can use this easily to just calculate it backward. Awesome. Thank you very much, everybody. Have a wonderful time.